Every single day, companies move literally billions of dollars worth of data across the public internet. So how in the world do they keep it safe? Well, they build secure digital tunnels. Today, we're going to decode IPsec VPNs, the blueprint for building those exact tunnels and connecting a global workforce securely.
So let's just start with the most basic problem here. The internet, for all its wonders, is basically a massive public square. It's incredibly useful, but it is not private, not by a long shot. So when you need to send sensitive company data from point A to point B, how do you protect it from, being intercepted? How do you keep your secrets safe in such a wide open space?
Well, here's the answer. You don't send it through the public square at all. Instead, you build a private, armored tunnel right under it. And that is the core idea of a virtual private network, or VPN. It creates a completely secure, encrypted pathway for your data, making it totally invisible and inaccessible to anyone on the outside.
So here's the game plan for this explainer. We're going to walk through exactly how to design one of these tunnels. We'll start with the basics, what even is a VPN. Then we'll get into the big choices you have to make, the type of VPN, the key architectural decisions, how to actually secure it, and finally, how to design it so it's built to last.
All right, so let's dive right in with that core concept, this idea of a private tunnel running through a public space. What exactly is a VPN?
At its heart, a virtual private network is the tech that creates that secure, encrypted connection over a public network like the internet. It's virtual because it's a private network built with software, not with actual physical wires. And the set of security rules that's most commonly used to build these tunnels, that's called IPsec, which stands for Internet Protocol Security.
So you might be wondering, why would an organization go through all this trouble? Well, this slide lays it out perfectly. The number one reason is security. Encrypting your data so no one else can read it, period. Then you've got privacy, hiding your location and identity. But for businesses, the real killer apps are remote access, letting your employees work securely from literally anywhere, and geographical flexibility, which lets you link up offices in different cities or even different countries like they're all part of one big cohesive network.
Okay, so you've decided you need a VPN. Great! The very first question you have to answer is, what or who are you trying to connect? Is it entire office buildings or is it individual people? This choice right here is what determines your VPN type.
And this brings us to the two main flavors of IPsec VPNs. First up, you've got the site-to-site VPN. Think of this as connecting your entire New York office network to your entire London office network. It's always on, and it makes these two separate locations act as one. On the other hand, you've got a Remote Access VPN, and this is for individuals. This is what you use when an employee is working from a coffee shop and needs to securely get into the company's private servers. It connects a single device to the network.
All right, so once you've figured out who you're connecting, you need to decide how you're connecting them. And this brings us to some key architectural decisions that are going to define the very structure of your secure network.
Okay, this first choice is a big one. Transport mode versus tunnel mode. Now, I love the analogy on this slide. In transport mode, you're only encrypting the actual data, the payload. The addressing info, like where it's coming from and going, is still visible. It's like an armored car carrying valuables. You can't get to the goods, but you can see the car's route. This is great for end-to-end security. Tunnel mode, though, that's a whole other level. It encrypts the entire original packet and then wraps it in a brand new one. This is like taking that armored car and its route information and hiding it all inside a big, unmarked truck. No one has any idea what's inside or where it's ultimately headed. This is the gold standard for network-to-network security, like those site-to-site VPNs we just talked about.
Next up, you've got to decide on the network layout, or what we call topology. As you can see in these simple diagrams, you can go with a hub-and-spoke model, or a full mesh. A hub-and-spoke model is just like an airline's network. All the flights go through a central hub. It's simple, it's cost-effective to manage, but, and it's a big but, it creates a huge risk. If that hub goes down, your whole network could be in serious trouble. A mesh topology, on the other hand, is like having direct flights between every single city. It's incredibly resilient because traffic just goes directly where it needs to. But as you can probably guess, it's way more complex and expensive to set up and manage. And this image here, it really brings that choice to life, doesn't it? Each one of those nodes is an office, and the lines are your secure tunnels. Your decision here is a direct trade-off. Are you going to optimize for lower cost and simplicity with a hub-and-spoke model? Or are you going to invest in maximum reliability and business continuity with a mesh network?
There's no single right answer. It really comes down to what your business can't afford to lose: money or connectivity. Okay, we've got the structure of our network planned out. Now it's time to talk about what makes that tunnel actually secure. We're talking about the protocols for authentication and encryption. This is, for all intents and purposes, the digital lock and key.
This table lays out our main options really clearly. For authentication, which is just proving you are who you say you are, you can use pre-shared keys. That's basically a shared password. It's simple, but it doesn't scale well. For bigger setups, digital certificates are the way to go. They're more complex, sure, but they're much more robust for a big enterprise. Then for encryption, the actual scrambling of your data, AES is the modern gold standard. It's super strong and efficient. You might still see 3DES out there, but that's really just for connecting to older legacy systems.
Look, building the VPN is really just the beginning. A network isn't some static blueprint. It's a living system. A truly great design has to plan for the future. And it does that by asking three really key questions. How will it scale? How will it perform? And how are we going to maintain it?
These right here are the factors that separate a temporary fix from a rock-solid long-term solution. Can it scale when your company doubles in size? Can it perform when everyone in the company is suddenly on a video call? Is there a backup plan for when, not if, a connection fails? And does it actually work with the tech you already have? A no to any of these is a future headache just waiting to happen.
And this right here, this might be the single most important thing to remember from all of this. Security is not a project, it's a process. You don't just set it and forget it. The real work, the hard work, begins after the tunnel is built, because it's a living system that needs constant attention.
So what does that continuous process actually look like in practice? Well, it's this life cycle. First, you audit regularly to find your weak spots. Second, you patch and update absolutely everything to close those vulnerabilities. Third, you monitor your network constantly to spot anything unusual. And fourth, and this one is so critical, you train your employees. The strongest tunnel in the world won't help you one bit if someone is tricked into just giving away the keys.
And you know, this quote from our source material just nails it. It really sums everything up. There is no single best VPN design. The best design is the one that carefully balances these three competing forces: the need for strong security, the demand for high performance, and the requirement to scale for the future. It's all about making the right trade-offs for your specific situation. Which brings us to one last really important question to leave you with. We spent this whole time designing a perfectly secure tunnel to protect our data while it's in transit. But what happens when that data arrives at its destination? Is the computer it lands on secure? Building the tunnel is absolutely crucial, but it's just one piece of a much, much larger security puzzle. And protecting the endpoints, well, that's a challenge every single organization is facing right now. Thanks for joining me for this breakdown.